Kalispera, everybody, and with that, my Greek is over. Sorry, but okay. So I am Matteo Mangiarotti. I'm a medical physicist, and I work for Varian as a software sales specialist. And today we are talking about QA in an adaptive world. So when we think about adaptive, in particular online adaptive, the first things that come to mind is ethos. As Tom previously said, ethos is based on 3 pillars. The first one is the initial planning phase. Then you go on the couch where the machine re-optimize and recalculate a new plan based on the conveniency of the day, so based on the new anatomy of the patient. And then you have the third pillar, which is the monitoring, where you can assess if your treatment is going as desired. A lot of automation is involved in this process, a lot of artificial intelligence is involved. So a question may rise here, is QA still needed? Well, as a medical physicist, I would say yes, because there are still a lot of potential pitfalls here involved. We still need to check the deliverability of the plan. We still need to check if the dose is going where the dose should go, if the PTV is covered, if the organ at risk are spared, and so on. So we still need to QA. We are all used to this kind of images. The classic way of QAing is to put a phantom on the table. You have different kind of phantoms, different kind of chambers, so you can measure the dose in the old way, let's say. But this process is time-consuming. And moreover, with the new machines, we are expecting that the numbers of IMRT and VMAT plans will increase. So these are the plans, so complex techniques where you really want to QA. So the time plays a big role here. And you also have to consider that with this kind of machine, the patient is on the couch. So you cannot put a phantom with the patient on the couch. Okay, you can say, but I will use my phantom before the treatment. So I can still use my phantom to measure the treatment. Yes, but you have to consider, as Tom explained before, that when the patient comes in, you acquire conveniency, so you generate probably a complete new patient, new plan. So you are no way to check this new plan. So you have to rethink the QA. Is there another way to QA? Luckily, the answer is yes. So we propose Mobius 3D. Let me take a step back from the adaptive world and let me introduce you Mobius as a program in general. So Mobius, it's our solution for secondary independent dose calculation. It's a vendor-neutral product, and it's based on three modules. We have the Mobius calc. So basically, you just need to export from your TPS the DICOM plan, the RT dose, the structure, and the CT images of the patient, and Mobius automatically recalculates with its own independent algorithm the dose and performs a lot of tests. I'll go into details of the test in a few slides. Then the patient goes for the treatment, and after the treatment is finished, the machine automatically sends the log file to Mobius. So again, the Mobius starts the new calculation based on the log file. So based on the actual position of all the axes of the machine. Let me stress the automatic here. Everything that you need to do is to set up an export filter from Eclipse, and with three clicks, everything is done automatically. In theory, you can set up the system so that it sends you an email if some test fails. Otherwise, you know that everything is good. All the QA are done, and the criteria are passed. The third module here is the ComBeam-CT module that we propose, and where Mobius basically superimpose the ComBeam-CT over the CT of the treatment and perform a gamma analysis based on the densities. So tells you really quickly if there is an anatomical change of your patient. Moreover, it can calculate the dose on the ComBeam-CT. So you can have a quick look and see how the dose is going, where the dose is going, better say. So here is how Mobius looks like. You see that you have all the checks for different tests. If everything is green, means that everything is good. If something is orange or yellow, means that there is some warning. Otherwise, red means that there is some error. If you want more details, you can go into the test. And, oops, sorry. And Mobius here shows you all the tests that it can perform. The first thing that shows you is a comparison between the DVHs calculated with the TPS algorithm and the Mobius algorithms. It can also give you information about the coverage of the targets with the two-dose comparison and with the sparing of the organ at risk. Then you can see a 3D gamma analysis of the two-dose distributions. This is really a 3D. You can go through every slice of your CT and see where the gamma is failing, if it's failing. And then we have a check about the position, the root mean square error of all the leaves and all the axes of the machine. Going back to adaptive, the solution is the same. So here is a brief loop of how the Mobius works in an ethos environment. So you just need to send the reference plan from ethos to Mobius, automatically starts the calculation based on the DICOM plan. Then the patients come in. When the system is re-optimizing and calculating the plan, just after the calculation is finished, the data are sent to Mobius, again, automatically, so you can check in real time with the patient on the couch if the QA is passing or not. So you deliver the treatment, and after the delivery, the log files goes to Mobius, and then again starts another calculation. So you have 3 checks for every plan performed by Mobius. What about adaptive offline process? In this case, we offer 3 products combined together to assess your objective. Again, Mobius, Velocity, and Eclipse. As we said before, with the CombiNCT module, it's very easy to trigger the need of a recalculation, replanification for your patient because something has changed. If the anatomy of your patient changes a lot, your gamma, based on the density, will trigger a warning for you. So you can then use Velocity to generate a new image based on the anatomy on the CombiNCT, which has the extension of the CT and the Ansfield unit of the CT. This new image is sent automatically to Eclipse, where you can recalculate the dose on this new image. And then again, automatically, the dose goes back to Velocity. And if you do this process for all your CombiNCT, at the end, in Velocity, you can obtain a map of the dose which has been really delivered on the real anatomy of the patient. And you can compare with the dose calculated at the first time. So you can see what you planned and what you really delivered. Here are some images of how Mobius looks like in the CombiNCT module. Here you can see that some anatomical changes occurred, so it's very easy to detect. You can set your threshold here, so it's very easy to see if something goes wrong. And again, here you have the CombiNCT with the dose recalculated directly by Mobius and the gamma analysis. Last but not least, some words about the efficiency of Mobius. With Mobius, at the end, you can easily increase the number of patients in your clinic because you will save a lot of time for the QA. You will free up LINAC time, and you free up also resources. The personnel is not needed anymore to put phantoms and to analyze data. All is done by Mobius. And also, the cost will go down because you don't need to spend money on phantoms and calibration of chamber and stuff like that. So are you ready to rethink the QA? Thank you very much.